You're back for some more asymptotes. So in theory, you've already watched the video on vertical asymptotes because it pairs really well with this video on horizontal asymptotes. It's much like potatoes and gravy, or french fries and ketchup, or sweet dough and cinnamon. Well, anyway, those are all things that pair together well, and horizontal asymptotes must pair well with vertical asymptotes. See this graph or this equation? We worked on this with the vertical asymptotes and we discovered this vertical asymptote type of behavior. Well, we're now going to take a look at this very simple graph with horizontal asymptotes because we said we don't know what's happening over here and over here. You might have a gut instinct, but that might be a guess. So let's figure out the calculus way to do it. The calculus way to think about horizontal asymptotes is as straightforward as this statement I'm about to unveil down here. Horizontal asymptotes are found by evaluating the limit as x approaches infinity and x approaches negative infinity. That's all it is. Don't add more to that. Don't take anything away from that. That's what it is. So if I don't know what this graph looks like and I wonder about the asymptotes, the horizontal asymptotes, this is all I do. So now this limit you might be able to do in your head right now. In theory, you probably think about this on paper. X is going to infinity, so X is getting huge. That keeps going on. What's happening to the trend in your Y values? My trend looks like 5, and the denominator is getting huger and huger and huger. That's going to close in on 0. Just because this limit is 0 doesn't mean this limit's going to be 0. But as you can see from the work I just scribbled, it does end up equaling 0 again. Maybe you need to pause to think it through. But my x values are going to negative infinity. My equation is 5 over something that's getting huger and huger, just has a negative sign. So that's also a 0. So I can translate this to that graph I had before. As x approaches infinity, my y values are trending towards 0. So now I'm going to kind of change this up. And as x heads to negative infinity, my y values are trending towards 0. Now it's just kind of a coincidence that I have the same 0 asymptote on the left as I do on the right. That doesn't have to happen. Sometimes you can have a left but not a right asymptote, or vice versa. So don't take anything for granted. Do your math, or as the British would say, do your maths. The horizontal asymptotes, though, are always based on this one simple statement that students are tempted to add to and subtract from, but that's all it is right there, people. So I've made up a few goopy looking problems, and you probably don't know what these graphs look like. There's a third one down there. You probably don't know what they look like, but you can find their horizontal asymptotes. So I'm going to go ahead and show you that work. I'll pause while I scribble it so you don't have to go through the pain of watching it. Here's my thinking on this first one. Simple statement, evaluate for horizontal asymptotes by doing the limit at infinity and negative infinity. So I'm going to concentrate on infinity first. My x values are getting larger and larger. What's the trend in my y values? Well, as my x values get larger and larger, the denominator gets huge. The numerator kind of stays around 2 because sine never gets much bigger than 0 or much smaller than 0. It's hanging around 0 to 1 or negative 1. So 0-ish plus 2 makes the numerator stay at 2. So the trend of 2 divided by huger and huger is 0. As I approach negative infinity, Now my numerator stays around 2 because 2 plus 0-ish. My sights turn to the denominator. As I'm approaching negative infinity, e to the x is getting very small. Remember, e to the x looks like this, and as I approach negative infinity, these y values are tiny. So the trend in my denominator is tinier, although it's staying in positive territory. So 2 divided by tinier and tinier and tinier, that trend gives me infinity. This ends up not giving me an asymptote because I didn't get a real number answer. This is an asymptote, so I can say horizontal asymptote of y equals 0. Let's do 2 more. We've got this one. I'm going to scribble my work. It would be wise of you to pause and think about doing it on your own and then comparing it to my work. Okay, I hope you took a look at this one. If I want to know horizontal asymptotes, I have to think limit at infinity or negative infinity. As I think about the limit as x approaches infinity, I did a little tiny intuitive t-chart over here, but I might be able to daydream this up. My numerator is continuing to get larger and larger and larger. My denominator, as I approach infinity, sign never gets really large or small, so my denominator hovers around 2. So the trend is a huger numerator divided by 2-ish in the denominator. That's trending towards infinity. That's not an asymptote. And I look like I want to now approach negative infinity, so I look like I want to start doing this, but we have trouble. Natural log of x will not accept negative inputs. So I can't even think about a left-hand asymptote. So I have no horizontal asymptote in this case. And we're going to do one final example. Taking a look at this one, I want to know a horizontal asymptote. See if you can figure it out. Horizontal asymptotes evaluate the limit at infinity and negative infinity. As my x values approach infinity, my numerator becomes so much larger than my denominator. That trend continues on forever and ever and ever. So this type of thinking leads me to positive infinity. That's not going to give me an asymptote. That's not a real number. But over here, as x approaches negative infinity, as I plug in these larger and larger negative x values, this piece trends towards 0. So 0-ish plus 6 makes my numerator hang around 6 or approach 6. That 3 is not budging at all, so it stays. So my trend is towards a 2, which means I have a horizontal asymptote at 2. With that graph. This concludes your education in calculus for horizontal asymptotes. If I were a man of few words, which I bet you wish I was, this is all I would put on the screen, and then I would turn off the video, because that's the bottom line. See ya.